Welcome to VINDAL'S Academy, and I'm very happy to welcome you to this Physics Paper 2 solution from 1 to 7. And this is going to be my part 1, and I'm going to do from 8 to 12, and that is going to be my part 2. Please don't forget to share this video, like, share your comment, but please be civil. I'm going to be running these questions, and I'm going to be using different pages. After a dual analysis of each question, I will go straight to a blank space, space, where I'm going to be solving my question. So please, I will prefer you do well to enjoy it. Sit down, relax as I take you through to all these questions. So we are going to be concentrating on number 1 to 7. This is going to be very interesting, and I'm sure you're going to enjoy it. So also, for those of you who are preparing for your waec, whether you're a teacher or you're a student, I'll be very happy to welcome your suggestions, your comments, and whatever you say that will make us achieve what we want to achieve. If you're ready, let's get started. All right, in number 1, remember from number 1 to 7, the physics question will always say answer 5 questions out of the 7, and each of them carries 3 marks. And I am going to be doing justice to each of them from number 1 to 7. All right. All right, let's see how we go to number 1. And the question reads, a stone of mass 20 grams. Okay, let me get my pen. A stone of mass 20 grams, this is the 20 grams, is released from a catapult rubber whose rubber is stretched through 5 centimeter. If the force constant of the rubber is 200 Newton per meter, calculate the speed at which the stone leaves the catapult. All right, I don't want us to waste time. This question is doing 2 things. There is something we call elastic potential energy, and then there is another one called kinetic energy, and these two comprise of a very special branch of physics in mechanics, which is called conversion of mechanical energy. So with this, let's go to the next page, having taken note of this and 5 cm. So simply put, this particular question is going to be saying that potential energy, which is the elastic potential energy of the rubber from the catapult, is transformed into the kinetic energy with which the stone lifts the rubber. If you can be able to write this relation very well, then your guess will be as good as mine. All right, let's see how it goes. I'm going to the next page, and knowing that you have all of the parameters, you've recorded them, let's go to the next page where I will do justice to it. All right, like I said before, and what is elastic potential energy? Elastic potential energy. It is given as, this question came in 2023 WIEC, where we asked to write this expression. It is given as 1/2 force. That means the average force times the extension. And then you also know that the normal kinetic energy is given as half mv squared. Now Remember, according to the law of conservation of energy, at any point, the total kinetic energy is going to be constant, but at this point, they are going to be the same. So half force times the extension is equal to half mv squared. So let us go ahead to, if I remove this f, remember that the situation whereby force constant according to Hooke's law is given as Ke. Therefore, the whole of this expression is going to be the same thing as 1 all over 2. Instead of writing this f, I'm going to write Ke. Then this is another E times E, which is equal to half mv squared. So this is the same thing. The whole expression is going to be half Ke squared, which is equal to half mv squared. They look alike, but please don't ever make mistake thinking that they are the same. They are not. So according to the question, the force constant in place of this K, the force constant was given as 200. Then the extension, according to the question, extension was given as 5 cm, but I'm going to divide it by 100. And when I divide it by 100, I have converted it to meter. And the extension is going to be squared. And everything is going to be 1 over 2. And then what is the mass? Let me take you back so that you understand what I'm saying. The mass is 20 gram, and this was this. So let's go back. So the mass is 20 grams. So what I will do is 20 divided by 1000. Why did I divide by 1000? To convert it to kilogram. And this is times v squared. All right. I will be I am going to boldly cancel these 2 zeros. Oh, sorry, I will cancel 1 0. I will cancel this 1 0 as well. So I have 1 0 left here, please. And this 1 divided by this is going to be 10. So I'm having 10 times everything here is going to be 0.05 all squared is equal to 1 all over 2, which is equal to, I think I'm messing with this question, which is going to be equal to, this is going to be, multiplied by 0.002 times v squared. And if I simplifying everything here, I'm just say in your calculator 10 times 0.05 squared, everything is going to be 0.5, which is equal to this divided by 2. Everything here is going to be given as 0.02 v squared. So v is going to be 0.5 divided by 0.02, and then the square root of everything there is going to be, please, sorry, struggling with this, my pen, but don't worry, I will get used to it, meters per second. So this is the question for number 1. The answer is 5 meters per second. All right, so let's go to number 2. Okay, look at the number 2 question. Number 2 is saying that the diagram above illustrates a projectile motion. Identify each of the physical quantities labeled P, but this one, which is beta, H, and R. Okay. All right, I'm going to do this one at this point. This B, this is called the angle of projection. So this B, or whatever they call it, beta, is going to be the angle of projection. Then P is velocity, the speed of the projectile. So P is going to be speed or resultant velocity, speed of the projectile, right? Then h is going to be the maximum height, then r is called the range of the projectile. So these are the things about that one for the question 2a. Now they say we should write an expression or write an equation to show the relation between PG and R max. When we talk about R max, I will do this one in the other part, please. On them, everything here should be clean. Somebody should wipe the board. All right. All right, so in this part right now, I'm going to have P. I will have R max. Let me check what is there. P, R max, and G. And then G. All right, whenever we talk about R max, we're talking about range of projectile at theta equal to 45 degrees. That is what is R max. So at that point, I'm going to have that R max is equal to U square, which is P. Since this one is the speed, that P is given as speed. So I'm going to write it P square sine 2 bracket. In place of this angle, I'm going to put 45 degrees there. All divided by acceleration due to gravity, and that is G. So at this point, 2 times 45 is 90. So whenever you have sine 90 degree, the answer is 1. So this is going to be P square all over G. So this is the equation combining R max, P, and G, and this is what it is. Okay, so let's go back to number 3. Number 3 says state 3 observable phenomenon in which wave behave like particle. Wave behave like particle. Do we have, or simply say that matter? No. So we say that it's either light behave as matter, as particle, or as wave. Light behaving as particle. Yes, this question should be a situation whereby light behaving as particle. State 3 observable phenomena in which light behave as particle. In which light, so this is supposed to be light behave as particle. So for light to behave as particle, there are phenomena that can make that happen. So the answer to that question is going to be 1. I can say photoelectric effect. Number 2, I can also say black body radiation. I can say number 3. I can also state thermionic emission. All right, so these are the 3 phenomena where light behave as particle. Number 4, list 3 magnetic elements. List 3 magnetic elements that describe the Earth's magnetic field at a point. Those elements that describe the Earth's magnetic field at a point and they are angle of dip. So for number 4, I thought I have a black pen. So number 4 is going to be I. This is the angle of dip. They say we should state it, so I'm not defining it, so there is no time for that. Number 2, angle of variation. Maybe in another video, I'm going to explain what each of these mean. And then number 3 can also be seen as horizontal component of the Earth magnetic field. So this is number 4. We have number 5 to tackle. Number 5 says, explain each of the following terms used in electronics. Okay, I can do that here because free electrons. When we talk about free electrons, we are talking about in a semiconductor when there are more negative charge. In fact, free electron simply means negative charge carriers. That means when there are more electrons which are free to move, we say that they are called free electrons. Where the negative charge carriers, I'm supposed to put carriers, I need to state it the way WIEC would like to say it. So free electrons are negative charge carriers in electronics. That is what the way it should be. Holes, when we talk about holes, they are positive. Holes are the positive charge carriers. Positive charge carriers in electronics. All right. And these are 3 questions as well. So let me try to clear some things I have written here. Let me clean. All right, let's solve number 6. Number 6 says, state the principle of operation of optic fiber. Of course, that is a total internal reflection. Total internal reflection. Total internal reflection is the answer. You can study. In terms of critical angle, you can study this principle called optic fiber. The principle of operation is based on total internal reflection. I will explain each of these topics in different videos. Number two is saying, all right, 6b. 6b says, stage 2 application of optic fiber in medicine. Okay. Laser surgery. Laser surgery is there, and diagnostic imaging. Some of these things, if you don't know them, for the sake of your exam, I am very serious. For the sake of your exam, there's no pretense about it. You need to memorize this thing. Diagnostic imaging, and then later you can, because some of them have to do with a whole lot of systems which some of you may not have in your school, but you can watch some videos which some of these concepts have been treated. And the last in this first part is diffusion, and we are expected to define diffusion. And I may not write everything. This is just the mixing of substance. Diffusion is defined as mixing of substance due to random movement of the molecules or particle, or simply mean that the movement of fluid from the region of higher concentration to the region of lower concentration in order to attain even distribution of those fluid or substances. Now, the next question says, state two factors that affect the rate of diffusion. That means for a substance to diffuse, the temperature must be there. Temperature of the environment is very important. Temperature of the environment, the first one there is temperature of the environment. You need to state that is the temperature of the environment, because if the environment is not, if the environment is damp, or is wet, is humid, it cannot. Number two is density of the substance. The substance itself that want to mix must have a density, must play a role for it to mix. Ladies and gentlemen, boys and girls, wherever you are watching from, thank you for being part of this lesson. Remember, the number thing to do, always subscribe to this channel, like this video, comment, and if you need any personal tutoring, if you're a student, you can always call me and send me a message. I will reply immediately. Thank you for being part of this lesson. Remember why I prepare to come for the second part, where we are going to solve questions on the second part. Thank you and bye.